Let's look at determining and classifying discontinuities. First set of questions, we have to find the intervals in which continuity exists. Okay, let's look at the first one. The function given is f of x equal to minus 2 cosec 2x. And we have to find it in this interval, minus pi to pi. Okay, so we know cosec is 1 by sine, right? So the continuity would exist between minus pi to minus pi by 2, minus pi by 2 to 0, from 0 to pi by 2, pi by 2 to pi. Now, how did I determine this? Basically, by figuring out at what point the discontinuity exists and excluding those particular points. So here, minus pi by 2, there is a discontinuity. Similarly, at pi by 2, there is a discontinuity. And there is a discontinuity at 0. In the previous session, we have seen how to find the discontinuities. Okay. So, second one, f of x is equal to minus x square minus 4x minus 2 when x is not equal to 0, and 0 when x equal to 0. So here minus infinity to 0 and 0 to infinity. Third one, f of x is equal to 2x minus 3 when x is less than or equal to 0, and x by 2 plus 3 by 2 when x is greater than 0. Now here minus infinity 0, but 0 is included, so square brackets, and then 0 not included to infinity. If fourth one, f of x is equal to minus x square by x minus 1. Now remember, in the denominator we should not have 0, so x minus 1 equal to 0 means x equal to 1. So x should not be equal to 1. So that means minus infinity to 1, and from 1 to infinity. The only thing is 1 is not included. Okay, f of x is equal to minus x square plus 3x by x plus 3. Again, denominator can't be 0, so x can't be equal to 0. X cannot be equal to minus 3, okay, which means the interval would be minus infinity to minus 3, and from minus 3 to infinity. All the values except minus 3 is the interval in which this function is continuous. 6 f of x is equal to cosec 2x. Again, this can be written as 1 by sine 2x. So wherever sine 0 is sine is 0, it is not. So when will it be 0? Because we have twice the angle. So it will be, and this we restrict it to minus pi to pi. Okay, so this would be from minus pi to minus pi by 2, minus pi by 2 to 0, and from 0 to pi by 2, and from pi by 2 to pi. Now just to verify, what we can do is we can draw the graph, right, and do the substitutions. Minus 2 pi is a complete anti-clockwise direction. Okay, so which means it comes back to 0. So sine 0 is 0. Now if we say minus pi by 2, 2 times minus pi by 2 is minus pi. So minus pi is a semicircle. So which is again 0. 0 in any case can't be. Again pi by 2 is nothing but in this direction. And 2 pi is complete circle in this direction. Now let's look at finding x for discontinuities. Okay. So seventh one, f of x is equal to x plus 4 when x is less than or equal to 1, and x by 2 plus 3 when x is greater than 1. So first of all, let's figure out what type of discontinuity. It is a jump discontinuity, and the discontinuity is at x equal to 1, because using the first, if x is equal to 1, it will be 5. F of x will be 5. Whereas here, if we get very close to 1, but greater than 1, so that means 1.01 by 2 plus 3. So we get 1.01 plus 6 by 2. So 7.01 by 2, which is 236,005, right? So here the first equation gives us 5, and this is 3.005. So there is a jump. Okay, eighth one, f of x is equal to x by x square plus 4x plus 4. Now denominator can't be 0, so x square plus 4x plus 4 equal to 0 means x plus 2 square equal to 0, which means x equal to minus 2. So it should not be equal to minus 2. So which means it is an essential discontinuity at x equal to minus 2. Okay, ninth one, f of x is equal to x minus 3 by x square minus 2x minus 3. So again here x square minus 2x minus 3 cannot be equal to 0. So let's figure out when is it 0. For what values of x equal to it is equal to 0. So let's factorize this. X minus 3, x plus 1 equal to 0. That means x equal to 3 or x equal to minus 1. So here again we have a discontinuity at these two particular points. But which type of discontinuities? So let's see, x minus 3 by x minus 3 times x plus 1. So these two get cancelled and we are left with 1 by x plus 1. Now this cannot be removed. So which means that we have a removable discontinuity at x equal to 3 and a essential discontinuity at x equal to minus 1. Okay, 10th one, f of x is equal to x minus 2 by x square plus x minus 6. So let's do it here itself, see whether we can factorize this. Let's say x minus minus. Now of 5 ones, no, 3 twos, yes. So 3 twos, this is plus, this is minus. So one of them has to be minus and the bigger one has to be plus. So which means here itself we can figure out x minus 2 is cancelling out. So which means there is a removable discontinuity at x equal to 2 and an essential discontinuity at x equal to minus. Okay, 11th one, f of x is equal to minus x cube plus 2x square. Now this can take any values. So it is a continuous function. There is no discontinuity. Okay, 12th one, f of x equal to x by 2 plus 3 when x is less than 3, and 2x plus 3 when x is greater than or equal to 3. There is a jump at x equal to 3. Okay, 13th one, f of x equal to 2x plus 4 when x is less than 0, and x square plus 2x when x is greater than or equal to 0. So again, let's take x square plus 2x at 0 is equal to 0, whereas 2x plus 4 at close to 0. If we get very close to 0 but less, so that means point minus 0.001 times 2 plus 4 will give us what? Minus 0.001, sorry, 2 plus 4, which will be close to 3. So here it is 0, here it is 3. So which means there is a jump at x equal to 0. Okay, let's look at the 14th one. F of x is equal to sine of 1 by x plus pi. Now here the denominator cannot be 0. So x plus pi not equal to 0, which means x is not equal to minus pi. And sine is a oscillating function. So there is an oscillating discontinuity at x equal to minus pi. Okay, 15th one, f of x is equal to x plus 5 by x square minus 2x minus, which can be written as x plus 5 by x minus 3 times x plus 1. Here, there is no cancellation, right? So that means there are essential discontinuities at x equal to 3 and x equal to minus 1. Okay, 16th one, f of x is equal to cos of 1 by x minus pi. Again, x minus pi cannot be equal to 0, which means x cannot be equal to pi. Pi minus pi is 0, right? So there is an oscillating discontinuity at x equal to pi. Okay, 17th one, f of x is equal to x when x is less than or equal to 0, x by 2 plus 1 when x is greater than 0. Okay, let's take this. Here it can be 0. So f of x equal to x. So which means it is 0 when x equal to 0. Whereas here f of x equal to x by 2 plus 1 when x is very close to 0 but greater than 0. So 0.0001, let's say. So what do we get? 0.0001 by 2 plus 1, which gives us 0.00005 plus 1, which gives us 1.00005. That means here it is 1, here it is 0, here it is 0. So there is a jump discontinuity at x equal to 0. Okay. 18th one, f of x equal to minus x square plus 4x minus 5 when x is less than or equal to 3, and x by 2 minus 5 when x is greater than 3. So first instinct says it has to be a jump discontinuity. Let's just verify it very quickly. So if it is 3, then with this it will be minus 3, no, not minus 3, 3 square minus plus 4 times 3 minus 5, which gives us minus 9 plus 12 minus 5, which gives us 9 plus 5, 14, so minus 2. Whereas here what happens? It can't be 3, so it has to be slightly greater than 3. So let's take it as 3.01 by 2 minus 5. What does it give us? 3.01 minus 10 by 2, which gives us 10 minus 3.01. So this gives us minus 6.99 by 2, which gives us minus 3.248, and we don't have to go proceed further also, na? Because this is not equal to this. So there is a jump discontinuity at x equal to 3. So that is determining the intervals of continuity and classifying the discontinuities. That's it. Bye.